But do not worry, we have the whole day ahead of us. So now we can start the second track, Decarbonizing Construction Materials. The founders you're about to hear from mix technology and science to create astonishing new ways to move the construction industry closer to the global net zero goals. Let's now discover more about their solution. This is now the time for jury to change places. In the first row, we would like to welcome the members of the jury for the second track. Decarbonizing Construction Materials. Thank you, judges, for being close and to react quickly. So now, let me introduce the members of jury. Robert Fisher, founder and CEO at Blue World Group. Larry Temonen, Director of Forecasting and Analysis at Sumitomo. David Garuffi, Head of Law, CEO to Built Environment and CRH. Rasmus Ude, Innovation Lead at Sunly. Jill Lindow from Bloomberg. Rushet Nanavati, Managing Director at Rocky Mountain Institute. Claude Sebastian Lerbourg, Director of External Ventures, Europe and Saint-Gobain. Matt Neal, Global Energy Resources and Incubator Lead at Endava. Harley Heiss, Innovation Specialist at Ørsted Wind Power. Hello, judges. Thank you for being with us today. Once again, I would like to repeat the rules. Each contestant now will have 3 minutes for the presentation. After the time, we'll still have 2 minutes for questions. Judges will have 2 minutes to ask additional questions to the contestant. Okay, so let's kick off the next track. Please welcome on stage Dom Edwards, representing Cambond. Production engineer. You have your mic and yeah. Thank you. The stage is yours. You have 3 minutes. Good luck.
Hi, I'm Dom Edwards, production engineer at Cambond. This was me a few months ago, in my previous employment, wondering how I could turn waste into resource in my own brewing process. Like many, I'm keen to reduce my environmental impact in the face of alarming climate change and dwindling natural resources. This is where Cambond come to the fore, with our award-winning bioresin. Traditionally, resins and adhesives are derived from fossil fuels, using huge amounts of energy to both extract and formulate. Not only are they incredibly energy intensive, they're also expensive and often contain large amounts of urea formaldehyde in their formulations, a known carcinogen under increased scrutiny and regulation. Cambond's patented bioresin, in contrast, is 99% plant-based, formulated primarily from spent grain from the brewing, distilling, and bioethanol industries. These feedstocks are available in increasing supply as the bioethanol industry grows and our love for beer and spirits continues. As a result, their valorization is needed to create more sustainable, circular economies to turn waste into resource. The wood panel industry is our primary focus, specifically the niche in the market producing formaldehyde-free boards. You may think a wood panel is simply just wood pressed together. However, up to 20% of the panel's mass can be urea formaldehyde resin, which slowly off-gases into our living and working environments, increasing the chances that you or a loved one may develop cancer later in life. These feedstocks, like I mentioned, are in need of increasing valorization, but our bioresin isn't just limited to the wood panel industry. We also have many other potential applications, including, but not limited to, biocomposites, a vegan leather that is currently in research, and a patented sea coating technology for agricultural use. Our patented production process is implemented by easy, scalable, and cost-effective manufacturing, ensuring a sustainable, biodegradable, and often food-grade product you can trust your health with. We're currently part of a UK Innovate project worth £7.3 million, with our key aim to scale resin production to 10,000 tonnes annually. We've just acquired equipment to make this a reality, although this is a drop in the ocean compared to the 1.5 million tonnes of urea formaldehyde-based resins used in the UK wood panel industry alone. Parallel to this, we have a joint venture in China producing our bioresin and biocomposites, covered by some of our 8 granted and 9 pending patents, across Europe, the USA, China, and India. We're currently quite a small team. Zhao Bin, our founder and CEO, and Gareth, his business development partner, myself and Joseph alongside, with Tara and Mike as business support, although we're really hoping to expand the team this coming year to meet the targets of our project. A few rewards and traction we've got, but thank you very much for listening. Remember to stick with nature and stick with Kanbond. Thank you.
Thank you very much for the presentation. Now it's a time for the jury to ask questions. So, are there any? Yes.
Hi, thank you for your presentation. I'm curious, are there other people working on sustainable resins, and how are you comparing to those solutions?
Yeah, so we know of a couple of other products on the market, one of which is a French resin, which is produced using soybeans. So soybeans, as well as the spent grain, have a lot of protein in them. But with their resin, they are growing the soybean specifically for use in their resin, rather than using it as a food source. So what we're interested in is taking waste and turning it into resource. And that is basically how we're sort of setting up to produce our resin.
Hi, thanks for the presentation, Jill Lindau. My question really relates to, I think, something that was referred to earlier with regards to McDonald's waste, I guess. How do you think about the pricing of your feedstock and what that does to the competitiveness of your product?
So we have currently just switched our feedstock. So originally we were using purely spent grain from the brewing industry, which obviously either goes to landfill or animal feed. So we want to use that and create a product out of it. The bioethanol industry, though, is growing hugely at the moment, and we've currently switched to use the spent grain from that process, which we're currently getting for free, although this may change. They're currently a project partner, and they're interested in seeing how we can valorize their waste product. But in the future, yeah, we may see a price increase and them asking for money for it.
Thanks, and good you're aware.
Hey there, Davide here. I have a question regarding your value chain. You mentioned you have specific application of your technology. How flexible it is to other feedstocks, and where do you see it happening in the coming, say, 3 years?
Yeah, so like I say, we used to use the spent grain purely from brewing. We're now switching over to feedstocks and bioethanol. Bioethanol can sometimes contain corn rather than just wheat and barley, which is traditionally used in brewing and distilling. In terms of how we can formulate it, there are many different ways we can formulate it. That's not my personal remit, but if you're interested, I can put you in touch with our CEO. But we do have some flexibility in the formulations for various applications. We have a dry resin and a wet resin. So the dry resin we use for our biocomposites, mixing with biopolymers and other biomass to produce our biocomposite plates and that sort of thing. The wet resin is purely for wood panel production, so using a wet resin to produce wood panels.
Dom Edwards, thank you very much for the presentation. Thank you, and good luck. The second contestant now is about to hit the stage. Please welcome Aaron Lucid, Partnership and Development Manager, Europe, Carbon Upcycling Technologies.
So hello everyone, my name's Aaron Lucid. So I am a business lead in the UK and Europe for carbon upcycling technologies. Our mission statement is to upcycle waste, capture carbon, and build a circular economy. One of the markets we already work in is within the cement and concrete sector, which is responsible for 8% of global CO2 emissions and has two major hurdles to decarbonisation. Firstly, there's an inherent release of limestone as part of the production of Portland cement. And when we look to reduce Portland cement in concrete, we look to cement replacements of low carbon. These are becoming more scarce. And the reason for this is that we're seeing an increase in demand for these products. And as other sectors start to decarbonize, the byproducts that we use currently are going to start to become more and more scarce. For instance, electricity, coal-powered, is reducing, therefore fly ashes. And as we move from blast furnace to arc furnace electric steel, we'll see a change in this sector. So what we do at Carbon Upcycling is we are introducing a new frontier of cement replacements by upcycling waste and natural minerals into superior, enhanced cement replacements. You can see on the screen right now an array of different feedstocks that we've proven our technology with, which are actually unsuitable to use without our process. So how does it work? So we co-locate our reactor technology at a source of industrial CO2. We then source a local feedstock, feed that material into our reactor technology. This then mechanically exfoliates the material and allows us to mineralize it with CO2 from that industrial point source, and therefore create a new reactive cement replacement, which is ready for use. So just to give you an example, we already have scalability. We successfully launched a pilot project, and we have 3 projects to deliver in the next 2 years. This one here in the UK with Cemex, with their rugby operation, is actually upcycling waste glass, utilizing the CO2 produced from that cement production, and therefore we're going to replace part of that cement going into their client base. So how are we doing this? So we've expanded our team from 10 to 26 in the last year to deliver on these projects. And in terms of our journey today, in 2014, we started this business in Calgary, where we're headquartered, and the reactor was the size of a cookie jar. And thanks to hard work and 12 million of undiluted funding, we scaled that technology 1 million times before receiving our seed round in 2022 for $6 million US. Since then, the team has expanded, and we've got more project commitments, and we're about to close on our Series A, and would welcome any conversations around that. So just to summarize is, we've scaled the technology efficiently. We have commercially viable solution. This is, a cost-benefit solution in certain markets, and we're building a team to actually, who are willing to take on the decarbonisation challenge. With our current trajectory, we will be the most impactful carbon tech business of this decade. Thank you all for your time, and anyone who wants any questions, please come to me.
Thank you. So now it's a time for questions. Yes, we have one.
I was wondering if the product has sort of any different performance characteristics and what the implications might be, therefore, for building practices, codes, stuff on the policy front that takes, or the construction practices front that takes, usually quite a long time to develop or change.
Mm-hmm. So yeah, that's a really good question. So we've tested this with a variety of feedstocks, and they have their pros and cons in terms of performance and CO2 uptake within the materials. What we do is, when we're working on these 3 projects that I mentioned, testing and improving compliance is part of that roadmap within the 2 years. What we find is, in some materials, like there is already standard and precedent there that we can utilize and improve our performance to that. But we can see this as a building up the TRR levels in terms of the applications that we utilize this in, and also the percentage replacement that we replace the cement with as well is a crucial factor.
Thanks a lot for the presentation. Very curious. I think I have a question in terms of, what's your business model on this, I guess? How do you commercialize this? Do you sell do you licenses? Is it selling cookie jars? Is it actually building plans and kind of the project type of work that you're looking to expand with?
Yeah, so currently all our operations are build, own and operate, and then we'll charge a tolling fee to the user of the material. But as we go through our next rounds of funding, the model will change to more of a licensing model, where we'll support the cement sector, the steel sector, to utilize their byproducts. You're welcome.
Yeah, I was wondering, can you comment about how this impacts the cost of the end product compared to current?
Yes, so it's, again, with different feedstocks, there's different value propositions to those materials. Some things like, say, for example, waste glass, we actually can receive a credit for that in the UK and European markets. So we are going to become very cost competitive. And for those who are familiar with the construction sector, we are really plagued with inflation at the moment. The price of cement, GGBS and viable fly ash has gone through the roof. So we're actually coming in as a cost solution in some of the markets that we're operating in globally.
Okay, thank you very much. Thank you for the questions. Thank you for the
Cheers,
presentations. Aaron Lucid. The second presentation, the third one, is about to start now. Please welcome Giandomenico Re from Enner Paper, managing partner. Hello. Representation from Italy. Good luck.
Nice to meet you. Enner Paper produce and sell material for thermal insulation based on cellulose. These materials in the market are typically are installed in flakes, either in attics, either on the roof, and provide the thermal insulation through the air that is trapped within the flake. The competitor in the market typically sell plastic bags full of flakes that are produced in dedicated plants. That beside the problem of having to invest for the production plant, the production process does not allow to have full optimization of the material. And therefore you need, when you are installing it, you need a significant density of the material. And by the way, you need also you have a significant effect of the logistic cost as you are transporting a plastic bag full of air in place of weight, let's say. Our idea come here, and our innovative approach is using paper rolls to be flaked during installation. More in detail, what's happened is that we are asking paper mills to produce paper rolls for us that are sold to the customer and installed through a dedicated machine. We don't have an issue on production capacity, as the paper mills has a significant capacity available, of course, and they are using 100% of waste material, waste paper, for the product. The process allows a much better flake. I can really show you the difference. This is because the flake is better, and overall we can reduce the density of material installed. So we need less material to provide a better insulation effect. Moreover, we really significantly reduce the logistic cost because we are moving paper and not air like the competitors. Overall, we have a significant reduction in cost, of final cost for the installer, and at the same time, we are providing better effect. We have something around 10% more insulation factor. This due to the fact that there is more air trapped within the flake because the flake is better, just to be clear. We are today active in the Italian market. We have done something around 600 installation overall, both on residential houses, small residential houses, and very big residential block. We have around 6 million of revenues, starting from 1 million of last year, more or less, just to give you some rough number. We are participated by Italgas Group for the Italian market, and we are looking for partners to enter the other European and the North American market that are unfortunately much bigger than the Italian one.
So sorry, I need to interrupt you. Thank you very much for the presentation, but now I really hope that you will have time to say everything you wanted, answering the questions of jury.
Thank you very much, great presentation. Claude Sébastien Herbourg from Saint-Gobain. I'd like to know...
You are a competitor, doesn't make sense.
Not yet, but
I can take
what kind of fire resistance do you have, and what certification do you have? Are you ready to enter markets like France and rest of the world?
Yes, we are already certified. Just to be clear, we are a European certificated, and we are also slightly certificated for the French market, that you know very well is quite closed. We have a resistance of B1 SD0 for the material into the wall, and we are Class C in the open, let's say, in the loose material. I mean, we have the best certification for the paper material because no one has 1D0 for, we have not seen anyone in the market with our certification. This is due to the fact that chemicals are put into the paper and not onto the paper, not on the paper. Because the paper mills directly produce the paper with the chemicals that are not hazardous like boron salt and stuff like this, different one, but are within the cellulose. So it's 100% waste paper plus the chemicals needed to provide a flame retardant capability.
Hi, Matt Neal from Indava here. Great presentation. Quick question. If you've done 600 installations and 6 million of revenue, I'm assuming that you've sold to consumers or house owners directly. If so, how do you see yourself expanding and what's the channel to market? And if you're still selling to consumers, how would you use technology to achieve that? And how do you see yourself scaling?
We have a situation in Italy that is very peculiar because in the Italian market, we are also installing the material. So we are making the 6 million also as an installer. We are selling the material to some small installer. For the Italian market, let's say it's a very peculiar one, very relatively small with high margins, so it's not really significant. For the foreign market, the scale is going to be relatively easy. We need to sell to provide the machine for the dedicated machine, probably in pay-per-use approach, what we are thinking. We are keeping the same price of competitors in terms of machine, but really we are not making money on the machine. We are making money on the material, therefore. So we are ready to rent the machine. It's not a big issue. In terms of scalability, as I said, as the production is done by paper mills, we don't really have any issue of capacity. This is very, very quick. In 2 days, they can make the production that we consume in 6 months, just to give you some numbers. I mean, if the president from Saint-Gobain can say if a paper mill can make 200 tons of material, 200,000 tons of material, it's something around, let's say, 200 million euro of just one paper mill. So
Okay. They are shouting at me, no? In my ear, I feel, I hear a lot of things now. Thank you very much, Giandomenico, for the presentation. Enter paper representation of Italy. Thank you very much. Still 2 presentations ahead of us. Now, please welcome Fernando de los Rios, CEO, Hyperion Robotics.
Hello, my name is Fernando and I'm the CEO of Hyperion Robotics. So, electrical substations, power transmission lines, wind turbine plants. We need to build a lot of these very fast and sustainably. But what else do these have in common that we cannot see in those pictures that I showed? Well, they need a lot of concrete. Concrete is pretty much everywhere. It's in every house, building, infrastructure. It's one of the foundations of our civilization, but unfortunately, concrete generates a lot of CO2. 2.8 billion tons of CO2 are generated every year. And concrete construction has barely changed. Very labor-intensive, time-consuming, and by 2030, 40% of skilled labor are going to retire. So what we are doing at Hyperion is we are combining design optimized with 3D printing and low-carbon concrete. We're transforming these big blocks of concrete into optimized, organically shaped structures, as you can see here, where we can save up to 75% of materials. We can deliver our projects in half of the time at least. We can save up to 90% of CO2 while staying cost competitive for our clients. And we can do this through our 3D printing microfactories, which can be off-site, or we can take it to the site, making the process more efficient, and also simplifying logistics. So something very important is code compliance. And code compliance is in our DNA. We have partnered with certified bodies in Europe and around the world to do testing regimes that are very strict, showing that our structures are durable and strong to comply with the codes. Something very unique is that we can print both with conventional concrete and also low-carbon concrete made from waste from the mining industry, steel industry, and paper pulp, and other different ones. And great evidence is this water tank, which is made from mining tailings, 97% recycled materials, 0 cement, and we can save 90% of CO2. And this was printed in only 90 minutes, so it's super efficient. We have a very unique and diverse team from 12 different nationalities, and also expertises in construction, automation, 3D printing, robotics, material science, and business. And today, we are selling the optimized elements to the clients, perfectly fitting into the existing supply chain. But in the future, we want to partner with big construction companies to be able to scale up our technology globally. We are already working with big clients in the energy sector, for example, Iberdrola, and we are signing new contracts with big energy players as well. We have raised 3 million, and we are preparing for a new funding round. So I invite you to join us in our journey, and let's 3D print a better future together. Thank you.
Thank you. Now, jury, have some questions.
Thank you for your presentation. It's Rick Baird speaking from Blue World Group. Fernando, I assume that you need to redesign every new structure you are building because, of course, you are meeting the code standards, but on the other hand, it looks like it's different. So give us a sense of how is the minimum amount, speaking of the lot units amount, you really need to redesign it, to making it sensible to redesign it.
Yeah, so thank you, Rick. So what we are doing is looking into, for example, foundations. Foundations are almost in any kind of project, right? So it's massively scalable application. So now that we have that concept of the optimized foundation, we can take it into different kinds of foundations. So we have done this job once, and then it's easier to replicate once we look into different kinds of projects. Right now, we are focusing on energy, utilities, and these kind of projects, but then this can be taken also to the building sector.
Hi, Fernando. Davide from CRH here. I have a question about your reference product. So currently, you said there's many concrete products out there, and what is your actual benchmark we're referring to? And you mentioned that compliance is your key, one of the keywords of your delivery. Can you tell us a bit more about, did you do any long-term or durability test or anything that makes your concrete products, available to the market and scalable tomorrow?
Yes, thank you, David. So maybe I'll answer this one first. So we are working with companies like Eurofins, for example, here in Europe. We perform different testing regimes from small scales of the materials, also small scale structures, all the way to full scale structures. And this allows us to both show to our clients that our structures can be strong enough, but also durable. Tests like freeze and thaw, carbonation, sulfate resistance, and these kind of things, but also certifying some of them. And then on the other hand, in terms of materials, perhaps the most standard is a more conventional cement-based concrete, but we have been doing some geopolymer concrete based off those mining tailings that I showed. So those are the main ones, and then we are exploring, collaborating with some big also concrete companies to see how we can scale this up.
Thank you very much. Thank you for the presentation. Thank you for the questions. Fernando de los Rios, thank you very much. The last contestant is waiting now, so please give a warm welcome to Franz Heller, CEO of Mixed Resting. Hello.
Thank you very much. Yeah, welcome everybody. My name is Franz Heller, co-founder and CEO of Mixed Resting. We heard it before from colleagues. Concrete alone, the building material, is responsible for 8% of global CO2 emissions. 8%. Why is this, you ask? Well, the building material concrete we're using every year, we're using astonishing sum of 23 billion tons of concrete every year. And the bad guy is the cement part. Cement part is responsible for the CO2. And the market size of concrete sold, 1.3 trillion, 1,300 billion US dollars is amazing. To put it into perspective, we're building a whole Mount Everest every year with concrete. So what's the problem? Just make this and you make a CO2-free concrete, right? No, that's the biggest problem. According to McKinsey, this construction is one of the least digitized industries in the world. Making and finding new mixtures are literally done by hand through trial and error, like children in the sand. What we do a software as a service solution to digitally simulate new and efficient mixes. And just imagine what you can do. Within 3 months, we guarantee you to find new and more efficient concretes with no change in quality. You have the same process in the plant. You don't have to change anything in the hardware. This is an amazing example of what the software is able to do. Within 3 iterations, our system found a wood fiber concrete which is CO2 neutral and uses 25% recycled aggregates. So the impact I'm talking about, just imagine the whole passenger air traffic in the world is roughly 1 billion tons of CO2. The concrete and cement is 4.3. Just imagine to reduce the cement part 10%. A reduction of 10% of CO2 means getting rid of all the CO2 emissions of all the air passenger traffic. How do we do this? As I said before, our digital platform, I can later show the software in action, helps the customer develop 10 times faster, new, more efficient concrete mixes. We're doing this as a well-experienced second-time founding, diverse founder team. Hermann is professor of mathematics who did all the IP. Walter is a trained architect who helped us in the development of the software. Florian is our key developer. He's a digital native. I'm the CEO, chief Excel officer, I always put it. And we're building our software. We want to change the world in the construction. We want to help the construction industry on the way to net zero. We managed to build our scalable software running on AWS with 750K. And now to scale this globally, we're raising 1.5 million. We're doing 10 paid POCs at the moment with one of the biggest names in the industry, not only in the concrete industry, but also in the construction industry, also working with a lot of startups. And I'm looking at the other colleagues from the startups. Maybe there are some potential customers for us. Thank you very much.
Thank you. Do we have some questions? Yes, we have.
Hi there. Working for a technology company, it's quite nice to see a software solution on stage. But I guess my question would be, I can understand why the software helps to design the concrete mix. But once you've got the design, why do you need to sell it with software? Why don't you just sell the ingredients? Help me to understand the role of software once you've designed it.
Great questions. There are 3 answers: money, money, and money. If you change a mix, the price of the materials is changing constantly, and the availability of the materials are changing. Like, for example, burner slag. If there is no coal, there is no burner slag. If there is changing steel. So each and every time some of the materials change, we have to adopt the mix.
Great, thank you.
Hi, Rasmus from Sunley. Question. So you sell the software, right, for the concrete players?
Yes.
Right. But once they get the optimal solution, why do they keep paying you?
Yes, as I said before, imagine that the cement is constantly changing, the material is constantly changing. For example, if you get new recycled aggregates, you have to adopt the mix as well. There is one easy solution to overdosage the cement, which is the most expensive part. So we help to reduce constantly the cement part to bare minimum, each and every iteration you can do. And the bigger the database is, our database is, the less iteration you need. Perfectly only need 1 iteration to optimize the mix. And this goes on and on, never stops.
Okay, so essentially you're making a market that's not really adapted to change, be in constant evolution. Okay, I like that if you can do that.
Thanks for the presentation. And I see what you mean with potentially some customers amongst the startups previously. My question is, maybe it kind of leads from the 2 previous questions. How would you commercialize it in terms of once they have the software? I understand why there's a case of needing to reuse it. Would it be every use? Would it be kind of a type of subscription? What's your view on that? Because as you said correctly, there's only a limited number of big players in the industry, right?
There are 600,000 potential customers at the world because the 30 biggest companies only have 5% of the global concrete market. The software as a service, we're starting from 500 to 1,000 euros per user per month. We're trying to get a login. One sample customer of Austria, he has 400 different mixes, and he only started to optimize 3. So just imagine if you have your database and you have 400 mixes in your database, why change? Because then you do all the work again. So this is something how we create the login in our software.
Great, thanks.
Welcome.
Thank you. Thank you very much. I believe time is
over.
Thank you very much for the presentation. Franz Heller, mixed arresting. Ladies and gentlemen, and just like that, the pitching time is over. Now the jury will vote to choose the contestant that they believe deserve to be the top in the category. So now it's a time for that, and we will let you know the results in a couple of hours. Now it's a time for a short break. We will meet here again around, not even around, at 3 p.m. So it's around 20 minutes. Thank you very much, and see you soon.